My name is Gabe. These are some of my probably collaborators. This is also like a few caveats. This is a team effort, so things in these slides, I'll say we, you won't know who that will mean. It's on purpose. Also, I'm going to burn through these pretty quickly, so don't bother trying to read what's on the slides or things. Just relax, listen to the sound of my voice, and let the vibes flow over you. All right, so this talk has 4 parts. We're going to get started by talking about, as the title is, which the title is Welfare Diplomacy, Benchmarking Autonomous Language Model Cooperation. Let's start by talking about diplomacy, and then eventually welfare diplomacy. Who here is familiar with diplomacy? It's a couple. Wow, okay, that's not peer pressure. You don't have to raise your hands. A couple of months ago, I was totally not at all. Here is a GIF of some human players playing diplomacy. It's a board game from 1959. You play as one of 7 European powers in the early 1900s, and you both move your military units across the board, and you also engage in diplomacy. You engage in sending messages to the other players in between each turn. Then you secretly make your moves, and your moves are all revealed at once. So this has some interesting conflict dynamics, interesting competition and stuff, as well as a lot of things related to forming alliances and making trust and betrayals as well, backstabbing your friends in order to win over the board. And here it seems like England conquers Europe. God save the king. You might have also heard of this from Cicero, Meta's paper from about November when they beat or solved the full press diplomacy, meaning they built an agent that scored over 90%, had over 90% win rates, top 90% of humans in an online league playing against other humans in the full press diplomacy. So meaning it's not just entering moves, it's also sending messages to people in natural language. And that was made by Noam Brown, who also solved poker for AI. And as Noam says in their lovely blog about this, diplomacy is a fun board game, right? But ultimately, we actually care about cooperation. We want AIs that can work in the real world and cooperate with us. This gets much more important when you realize people are not just using language models per language model. They're also deploying these as agents in this world, and this gets concerning when we don't really know what those agents are doing. So the big theory of change here is when we're in a world with many multi-agent systems interacting, representing our values, and making autonomous choices on behalf of us, are we going to like that world or not? I claim that base diplomacy is not the best way to represent this, hence we made this variant, which we call welfare diplomacy. So classic diplomacy is something called zero-sum. It basically just means that you have to compete over the territory. There's always one winner, and winning is at the expense of other people. This also makes it harder to measure how much cooperation is happening versus pure competition, because the number of territories you get, which is the supply centers, determines victory, is also the number of military units you can build. And so people are basically always warring. In welfare diplomacy R variant, the TLDR of the rule change is you can demilitarize, and this increases your nation's welfare. And so there's this trade-off between welfare and militarization, and welfare is ultimately what counts at the end of the game. You have to just maximize that, and this makes it general sum, because you can actually create more welfare for everyone through cooperation. This is both more realistic to the general sum world we live in, and hopefully trains better incentives for AI models. So next, let's talk about the methodology we work with. And overall what the project was about. If you want, you can read more there for some reason. First, we're going to modify a diplomacy engine that other researchers have built, so we can actually train AI agents or test AI agents in this environment. That was pretty simple. We also asked some members of the community for feedback on this variant, on these rules. Does this actually check out to people who know a lot more about this game than us? And third, we're building a competent agent, a baseline agent we could actually do experiments on. I'll come back to that in a second. Then we'd run experiments on them, see how cooperative they are and other things, publish these things, and hopefully this makes stuff go better for the world. So let's come back to that third part, because that was the most uncertain portion of this project. Basically, we first turned it to Cicero, of course, the state of the art. How do they do it? They are quite clever. They have some really advanced models, right, in order to perform at such a high superhuman level. However, and they're also, I should say also, their code is open source. Their models are open source because it's meta. They like to do that. Their appendix is 82 pages. Their methods are just really complex. We didn't really want to do this, so we decided to go for a simple method, which is prompting language models, just prompt engineering straight up. Overview of stuff, more words you do not need to read. It's basically we just tell the models they're playing diplomacy. We tell them our special rules. We give them some state about the game and some things that are useful in order to make competent moves. And then we ask them to respond first with some reasoning, to think out loud about what they should do, and submit some orders, and then send some messages. This is what that looks like. Again, a lot of words you don't need to worry about. Just note that It's like doing some reasoning out loud, thinking privately to itself. This also allows us to introspect into the model's cognition a bit more, and then choosing some orders that they'd want to execute and sending some messages to the other players in the game. And here's what that looks like. GPT-4 actually works with this. This is the first one we did a couple weeks ago with GPT-4, playing 7 players against itself. You can also, if you want to look at the run later, it's there. What we see here is that the powers expand early on to the neutral supply centers. So there's some territories that aren't owned by anyone at the start of the game, and they expand to these and claim them, and there's no fighting necessary for that. And then they, over diplomacy, over like sending messages, they agree to peace. They're like, hey, I won't invade you if you don't invade me. Are we cool? And they actually are quite cool with each other. They eventually disarm themselves fully and reap in a bunch of welfare points. This is basically what we desired. So with this, we had like a good baseline. We thought that GPT-4 would be enough, and we could actually do some experiments with it. We also did a bunch of logging of things. If you are other ML people, we would recommend weights and biases for graphing a lot of things over the course of our training to allow us to actually get some more results and look at the experiments and have a much more refined sense of how these models are behaving. In particular, it's really useful to actually see the state of the board. So when we have experiments running, we can like go look online on my phone or something and see how these models are duking it out, which is quite useful. Okay, so what are the actual experiments we ran? We had a more complicated plan. Now we've like simplified our plan down into 3 main categories. That's the magic number. First, doing a bunch of ablations, meaning changing some stuff about the environments and the models and the prompting we use in order to both like test, is this a valid benchmark for people to use, and to get more of a sense of how these different factors affect the agents. Additionally, we're doing some self-play benchmarks, so pitting certain kinds of agent policies together, which for us mostly just means different language models, pitting them against each other. Putting them in against themselves, so like a bunch of GPT-4s playing together or a bunch of Llama 2s, for example, seeing how these different models perform in some kind of self-play benchmark sense. And then some asymmetric sense, some kind of exploitation things. I'll get to those in a second, but basically we want to see how are these policies against other policies that are trying to exploit them. This seemed like a good plan to us. We were like really happy and designed our experiments and started running things. Then we ran into a problem in the form of we ran out of money. We had a grant from OpenAI, but quickly burned through these. The diplomacy is not a simple game, and there's like a lot of communication involved. So it took like about $100 of OpenAI credits per run and 3 hours. And so yeah, that's burned now. We're kind of waiting for some more help from OpenAI. So that's kind of the main blocker to our progress so far. But I'll show you some like preliminary results and some Claude runs. Claude's not as good, but it's all right. So of course, we did some ablations on prompts. Here are like a bunch of different changes to our prompts, and these make the bars go left and right? So these show that there are some things we might want to change about the prompts, or some things that don't matter, or some things that when we remove them, the agents do much worse, which is useful for us to know. We also, of course, tried to compare welfare diplomacy to classic diplomacy, right? Do we actually need the separate variant? What happens when we put models in the base game? Here are graphs of basically like how much conflict and how much stealing of land happens, and oh, there's a big difference between the bars, right? This is something that's desirable in that welfare diplomacy seems to incentivize more cooperation, less conflict than standard diplomacy. Also doing some other ablations of how we sample from the models, for which interestingly, if you make the models more random by turning up the temperature, they seem to do better on a lot of fronts. Maybe they're more creative in some sense and able to find better solutions that way, not totally sure why yet. Then for the self-play experiments, we've only done a few models so far, and with like very limited trials. This is going to get better over time, but TLDR, GPT-4 is better than all the rest, surprise, surprise, both in terms of capabilities. This is like how often it submits valid orders, and in terms of some senses of how good the performance is, how cooperative they are, how much welfare points they're able to accumulate. As we can see here, GPT-4 is this purple line. And also, if you look at messages, Claude likes to send a lot. Claude's very chatty for some reason. Last, perhaps most interestingly, are these exploitability experiments. What we're interested in measuring here is not just when you have some agents that are like happy and like playing with copies of themselves, how do they behave? You also are interested in how do they behave against adversaries, right? When you have some policy in this multi-agent environment, what's the best response against that, and how exploitable is that policy? Here is like a trial with Claude. Claude's not the best at exploiting itself, but there's some stuff that happens. Basically, we just don't read all these words. We just tell some of the agents, like, hey, you have secret instructions, and you're going to team up against all the rest of them. And the rest of the agents are probably going to be peaceful and trusting, so exploit them and be power-seeking and deceptive. And we've not examined this too close yet. We have a lot of data to look through, but it seems like the models are somewhat able to keep war going throughout the game and expand, and they basically take out Austria. Sorry, Austria there. This, I think, is Russia and Turkey together in the Juggernaut alliance, which is common in the base game. So there's some exploitability happening. It seems possible that these models are just too trusting in some way that could lead to catastrophic failures when pitted against exploiting models. We also have some proofs here that we're going to do, because it seems like you're able to show some Nash equilibria exist. And if you look closely, there's even a dublog for Jesse. As for our future work, because a lot of this is still unfinished, but we hope this will result in a few different paths of impact. First, we're submitting to iClear in September, so there should be a paper you can actually read with proper graphs in about a month. We're also maybe going to be working to set up a competition for this, working with the automated negotiating agents competition, so that other researchers can actually compete to make better agents in this environment. Also, we'd like to ideally test this with humans more properly. We've asked a lot of people online who are pro-diplomacy players what they think about these rules, and got a lot of feedback there that was useful, and a lot of intuition about why our variant might be good or bad. That will be really useful for contextualizing the paper. But it's also, of course, great to do real human trials. Problem is, this takes probably over 4 hours or more for beginners, which is why we didn't do it in ERA. Sorry about that. As for the impact, though, we think this project directly, as well as some follow-up work, has a few things we're excited about. Most directly, it's creating better agent evaluation benchmarks. Really, most of the benchmarking people do with AI models today are in single agent environments. It's how does GPT-4 behave just like operating a web browser itself, or just doing math itself, or things like this. It's really uncertain how multiple agents work together, and agentic systems, autonomous systems in general, rather than ones that are just answering questions. Also, it's important to separate cooperation and competition and collusion. These things can be very intertwined. It's not always clear when we have agents that perform well in multi-agent environments if those would also transfer over in safe ways in the real world when they're representing human values, and there's a principal-agent, multi-agent interaction. Also, perhaps, we hope this kind of work is more foundational and engages other researchers to get more involved in multi-agent language model agent evaluations, these kinds of works, both in terms of evaluating agents and training better agents. And as we're doing this, we might find some more cases of misalignments in some sense, or cooperation failures in more of a multi-agent sense, that are useful to share with other stakeholders. For example, the exploitability might be an important thing if you think of LM agents that are representing your bank account or your country online. You don't want those to be too exploitable. And maybe these kinds of cases help buy time if we share them with, for example, the task force and other stakeholders like that. And last, this has also been useful for personal development, career growth, all those lovely things. So that's a wrap. Special kudos to my mentors, Alan and Jesse, and also Tillman, my research manager. Would have failed a long time ago without these people. And for everyone listening, thank you for your time.